morning, good afternoon, and good evening, depending on where in the world you're joining us from. Welcome to our webinar, Geospatial Data Science at Scale with Esri and AWS. I'm Brian Mink, co-founder and president of Data Science Connect, the world's largest data science community. Today, we're excited to have nearly 500 attendees from all over the world to discuss geospatial data science at scale. Industry analysis firms estimate that the global geospatial analysis market will grow to over $34 billion by 2032. Geospatial analysis tools and capabilities are more important than ever to help organizations efficiently process and gain insights from spatial big data. In this webinar, we'll explore how to bring spatial analytics directly to your big cloud environment. We're excited to bring you leading experts at Esri and AWS who will demonstrate the power of ArcGIS GeoAnalytics Engine, a Spark native library paired with AWS EMR to effectively scale analytics to the size of your data and generate actionable insights to improve decision-making. Our distinguished experts today include Sarah Battersby, Senior Product Manager at Esri, Damion Harrylal, Senior Software Architect at AWS, Arif Masrur, Senior Solution Engineer at Esri. Before we begin, a few housekeeping items. To make this feel a little more in-person, we suggest you add a photo to your profile and include your bio, LinkedIn profile, and other information that you want your fellow attendees to see. Also, please take advantage of the Q&A and chat features throughout the talks. We're dedicating a portion at the end to Q&A, so be sure to upvote the questions you'd like the experts to address. Finally, check out the poll questions in the right sidebar to gauge where your organization is in its geospatial data journey. Now, without further ado, I'll hand it over to Damion Harrylal.
All right. Trying to see the screen. Okay. All right.
Sorry, my controls are.
Yeah, no worries. All right. Hi, everyone. And yep, there we go. All right. Hi, everyone. Welcome to Geospatial Data Science at Scale with Esri and AWS. So today we're going to run through a couple slides and talk about how Esri and AWS can help you with this issue or problem. So Esri and AWS, we help combine the power of GIS and power of innovation of GIS on AWS. So products that run reliably and securely on AWS. AWS provides fast, reliable, scalable, and resizable compute capacity to be able to handle some of these workloads. And some of the software we're going to be touching on today is, ArcGIS Enterprise, GeoAnalytics Engine, and some of our Spark and EMR notebooks. Next slide. Yep. So we actually have a dedicated team of a couple individuals here at AWS. We're the only CSP with a dedicated team to AWS. So there's me highlighted in green, and then we have a couple other people on the team. Together, we have like over 60 years of experience with Esri and AWS. So we have very similar DNA to companies when it comes to customer obsession. Our teams both strive to make the customer experience the best it could be. So we've been a first Esri cloud partner since 2008, and we have a deep partnership with ArcGIS Online as well as Esri internal businesses. We're also fortunate to have a very strong relationship with the Esri partner community as well. Next slide. So the Esri AWS partnership began quite a long time ago, back in 2008, when Esri created their first account on AWS. And since then, we've tried to maintain that deep technical and business partnership focused on ensuring that our customers have the best-in-class software and technology behind their ArcGIS cloud deployments to remain successful and be continuously improving. So through the years, we've done a good bit of work together to join each other's APM programs, but also that deep technical integration where we have some integrations announced between ArcGIS and Redshift, and one that we're going to talk about today, which is GeoAnalytics and the Amazon EMR integration. So next slide. So how do we partner today? So today there's a global alliance between AWS and Esri, and we're supporting each other in strategic business alignment to provide the best technology platform for our users. This comes in the form of migrations and modernizations around tooling. So through the AWS Migration Acceleration Program, CloudFormation, backup, WebJS DR from Esri, and that leads into some extra technology. And some of that technology is actually where AWS and Esri partner to bring some of our services and the Esri technology together. So today, the focus is going to be around the ArcGIS GeoAnalytics Engine and Amazon EMR. So we're going to talk about supercharging your data analytics pipeline on the AWS cloud. So it's going to be, there's a diagram here about the workflow, the basic workflow of how things are going to move through the different applications, but it's going to come down to 4 main headings: configure, connect, analyze, and publish. This is kind of where AWS make things a little bit easy for you without having that deep understanding of being able to build this from scratch. So from configuring, we're going to break it down where AWS helps build that infrastructure through Amazon EMR. We do all the setup of the notebook, in the engine, the notebooks, the studio, and actually create all the infrastructure on the back end, making it easier for you to then connect to your existing data lakes that are on the same platform, be it in S3 or data that you pull in to different parts of the infrastructure. Then you're able to connect that to do the analysis on it, which we're going to walk through the GeoAnalytics library, Jupyter notebooks, and then have that data come back out either back into S3 or into some of our BI applications like Amazon QuickSight. And with that, I'm going to hand over to Sarah to go through how we're going to do this today.
Okay. Thanks, Damion. That was a great overview of analytics in AWS. So what I'm going to focus on now are the specifics of spatial analytics and data science within the AWS environment. And when I think about what that entails, I'm considering a pretty wide range, everything from data engineering, visualization and exploration, spatial analysis, modeling and scripting, and sharing and collaboration. So of these, not all of them are explicitly spatial, but all of them can include a spatial component. And that's whether we were talking about data engineering, where we're actively working with our raw data to transform it into usable information for our workflow, which could include spatial enrichment to attach new attributes to records based on location. It could be creating or cleaning geometry, like snapping GPS points to road segments, identifying spatial outliers, or a lot more. Or we could be talking about visualization and exploration. So that might also be spatial with viewing maps, just in addition to the standard visualization of data distributions that are common throughout our data science workflows. Of course, spatial analysis also involves spatial analytics. And then we have our modeling and scripting and exporting data, which may or may not rely on spatial operations specifically. So to take a step back just for context, let's dig in on that spatial analytics portion specifically, because it can take many shapes within an analytic workflow. So for instance, it might be explicitly spatial, where you're generating mapped output at the end. So just as a few examples, if we start from the left, we have an aggregation of point locations into hexagonal bins, and that allows us to more easily see the distribution of our data and how it clusters together in different areas. It's a great technique when you have really large data sets. These points could be stores or customers, traffic accidents, UFO sightings, anything that you can attach to a location. Next to that, with the blue and red, we see hot and cold regions on a map. So this is specifically spatial analysis where we're looking for areas where we have statistically more or less of an attribute of interest relative to local and global distributions of the data. Or we could be looking at connectivity questions, like the last two images on the right. For instance, where are patients relative to the nearest hospital? How far are the distribution warehouses from our stores? Or any of these questions that really get at the linkages between locations. All of these can help you visualize and understand your data in its real-world context. But I want to note that spatial analytics doesn't always mean making a map. The estimate I've seen is that 80% of business data has a spatial component, and that's something, pretty much anything that can link a data record to a location. So it might be an address, a zip code, hospital name, or any number of different identifiers. But having that spatial link means that you're going to be able to, of course, visualize the data, but you could also use it to connect to other data sources to add value. For instance, if you want to build up demographic profiles for all of the users in your database based on their location and use US or foreign census attributes, and then you may not use those in a spatial model, but you may want to use them in some other sort of model where you're going to predict spending behaviors based on these characteristics that you've attached to people based on the location. Location is still at the heart of the analysis, but the analysis doesn't always have to be explicitly spatial. And this is the type of analysis that's really at the heart of what Esri does. So Esri is the world leader in location analytics and geographical information systems. We're trusted by more than 10 million users worldwide across all sectors, whether you're talking business, education, utility, government, it kind of goes on. I think this partnership between Esri and AWS really brings the power and intelligence of both environments to make spatial analytics a first-class player in your workflows to drive decision-making in your organization. Because with this combination, you can seamlessly integrate spatial in your notebook alongside all of your traditional data science workflows. And I just want to take a second to put this intelligence and location intelligence comment in perspective. So just a little bit about me. I spent a lot of time thinking about how people think about space. My dissertation research was all about cognitive cartography and how people understand mapping. And one of the things that I like the best about the Esri technology I work with is the care that goes into helping people just ask the spatial question. So the software can do some manipulation behind the scenes to make sure all your data line up, and you can focus on the questions and be less concerned about how to make everything work. So for instance, this idea of map projection on the fly, I love map projection, so it's one of my favorite topics. So long as we know the coordinate system for your data, we can do a lot to just make it work. So let's look at a quick example. Let's say we have some point locations, and these are around the Boston area. They look great on the base map. We can see a little distribution. I mean, mostly what we can see is that there are a lot of points, and they cover the whole area. And what we want to do is aggregate the points into some nice hexagonal bins. We want to get a sense of their distribution. And in our mind, this is what we think we're about to do. We've got polygons, we've got points, they're all nicely lined up on the map. We're just going to count based on which polygon each point falls into. And we're expecting we're going to see a result kind of like this. A nice count of points inside each of those bins so we can see how the pattern changes across space. But what we really have are these orange bins. And these orange bins are very much not rendering over that same area on the map. In fact, they're right in the middle of the ocean, because it turns out that the coordinate systems are different between the points and the hexagonal bins. One is in latitude and longitude, and one is in a local coordinate system. And many tools for working with geographic information, that means you just won't see any points inside of the polygons because it doesn't see these coordinate systems as lining up. So for each one, you're going to count up the points inside the bins, and you're going to get a count of 0. Because the computer sees them like this last map. Points are in Boston, our hexagonal bins are in the middle of the ocean. But one of my favorite features in GeoAnalytics Engine is so long as we know the coordinate system, we're going to make it easy for you to just ask the question, because that's really what you're here for. I just want to ask questions and understand my data and work with it. Tell me how many points are in each of these polygons. And even though they're in different coordinate systems, we can just reproject behind the scenes for you. You don't have to make a duplicate copy of the data. You don't have to remember to add a line in the script to update the projection. We're just going to do it when you run the operation on the data sets. And I love that sort of thing about the technology. We allow people to just focus on asking and answering those critical questions. Now we do this with a product called GeoAnalytics Engine. And this is a cloud-native, Spark-native library that enables spatial analytics within Amazon EMR. Traditionally, the spatial analytics workflow has been you pick up your data and you move it to the GIS, or the Geographic Information System. But that's not necessarily efficient or practical for big data environments. So we're going to pick up our analytics and move them into your environment to run natively in Spark. So we just take all this stuff and we drop it into EMR, and you can access all of your data. So with this, you get ready to use spatial analytics with a fair bit of special intelligence built in. For instance, you don't need to build your own spatial indexes, and we can take care of optimizing that. So you can just focus on that core part, asking and answering the questions. It's also easy to get the results where you need them to ensure consistency and to ensure you have your single source of truth. Whether you're writing back to a data lake, a data warehouse, or you want to push the results into a spatial database or use them in your BI applications, using the built-in Spark functionality and the ability to natively write many common spatial formats using GeoAnalytics Engine, you can just get the data where you need it. The way this works is that within your AWS environment, you configure your Spark cluster. From there, you access your cloud data repositories to identify the data to analyze. The data analysis is done via a Python notebook using GeoAnalytics Engine in conjunction with any of the other Python libraries relevant for your analysis. At the end, you write results back into your cloud data source. So let's just take a few minutes to look in more detail on what's under the hood. GeoAnalytics Engine works in a standard notebook environment. So once the GeoAnalytics Engine files are in your EMR environment, the only special thing you do to enable the geospatial functionality is to import the library and authenticate. And then it's just like any other Python library that you would bring into your workflow. You can read data from an S3 bucket or any linked repository. Essentially, if you can read it or read from it with Spark, you can read it in GeoAnalytics Engine. Plus, you're going to have access to specific functionality for reading and writing spatial formats. So shapefiles, GeoJSON, file geodatabases, feature services, GeoParquet, and more. Using Matplotlib, there are built-in options for spatial visualization as well. And you can use one of 4 different Esri provided base maps. And these are going to allow you to examine those intermediate steps or results as you work through your analysis and to bring in scale-specific context to better understand the patterns in your data. So it's not just you're plotting points on top of a white background. You're plotting them on top of a base map that gives you that context to understand the distributions in your data. But with GeoAnalytics Engine, it's not just that you can read, write, and visualize data. I mean, those are definitely nice, but there's a lot more to analytics than this. So what's great is the GeoAnalytics Engine is providing all of the building blocks for just about any analyses that you need to do. For a few examples, importing and creating geometry to set you up for analysis. Because you might just have a table, maybe a big CSV or a Parquet file with X and Y coordinates. You can't just drop that onto a map until you turn it into a geometry. So you can easily turn that into a geometry to visualize it and analyze it using GeoAnalytics Engine. This example here is a table of about 2.5 million point locations that were defined with latitude and longitude. And we just use ST point, we set the coordinate system, and we turn those into points and we can plot them quickly to see the distribution. Or you might have addresses, and actually with our upcoming release, we're going to have the functionality for geocoding to turn those strings into location. Or you might have a well-known text string or well-known binary, and those can be converted into your points, lines, and polygons as well. But just building off of that example with 2.5 million data points that we can just drop onto a map, when you're working with big data sets, looking at that raw data really may not reveal many patterns other than you have a lot of data. So aggregation is one of the steps that can help uncover patterns. For instance, here we're using hexagonal H3 bins to look at the total number of points in each location. And since this is actually representing insurance data, we can look at the total count, or we can aggregate and see the total insured value in each bin as well. And natively, GeoAnalytics Engine is going to support square bins, hexagonal bins, and the Uber H3 bins really easily. So this is a great technique for visualizing patterns, as well as for simplifying your data for later visualization, for instance, to push it into a BI product. Another common workflow with spatial data is to enrich your data so that you have greater context for modeling. For instance, taking point locations for customers and assigning attributes to each of them based on their location. In this case, we're looking at socioeconomic data from the US Census. And since we know the location of each of the points, we can quickly perform a spatial join to make our table of data about our customers a lot smarter. And this particular example is a containment relationship, which points are inside each polygon. But there are a lot more options. For instance, if you wanted to enrich each point with the attributes of the nearest hospital or store, it's just a different spatial relationship. And GeoAnalytics Engine supports about a dozen different spatial relationships. There are also specialized tools and functions for calculations like proximity analysis and assessing connectivity between locations, finding hotspots, and for cleaning and standardizing data. For instance, snapping your messy GPS points onto their road segments. And many of these computations can be done with both spatial and temporal constraints. So for instance, if you had a really specific question and you wanted to know something like every time a vehicle passed within 100 meters of a sensor of interest or a location of interest, you can do that by setting both a spatial constraint and a temporal constraint in most of the analytic options. But many of those examples were based on sort of the raw building blocks. You know, kind of individually, these functions and tools provide a lot of value in your analytics. But when they're combined, you can answer a lot more complex questions. So this example here is looking at where people co-located in time and space and where they were before and after. So, I mean, perhaps we're looking at a public safety or a human intelligence question, and we want to know something about a location of interest. In this case, this dashboard is based on a location in the Washington, D.C. area. And we want to identify something like dwell locations. How long were individuals stationary in a place of interest for a minimum period of time? Perhaps they were lingering longer than one might have expected. We can then look at the GPS tracks for each of these individuals to see where did they go before, where did they go after. We can also look at who overlapped in space and time, and where, and when. For instance, there was information being communicated in person, or there was a drop of information and someone else came to pick it up. We can try and pull that out by combining these functionalities, these basic tools and functions. Together, they're going to answer some really complex questions. The analytics can be combined with other Python libraries that you're working with. So for instance, if you want to incorporate spatial data into a machine learning model. And in this case, just these few examples here, these graphics, we've woven together a number of libraries to look at patterns and predict rideshare demand, which is the example that my colleague Arif will walk through in just a few minutes. Before we get there, I just want to show a few additional elements of GeoAnalytics Engine. It's bringing around 140 spatial functions, which work at the row level and enable you to craft the functionality you need. The functionality includes constructors, accessors, operations, relationship tests, and special functions for spatial binning. And there are also the vast majority of spatiotemporal analysis tools that you may be familiar with from other geospatial products, including aggregation, spatiotemporal joins, pattern analysis such as density and hotspots, as well as some machine learning tools and movement analysis. In our upcoming release later this month, we'll also be introducing solvers for geocoding and several types of network analysis, which will open up a lot of new doors for enriching your data and exploring patterns. I would say, just in general, I think GeoAnalytics Engine is a valuable component for powering end-to-end workflows in AWS and ensuring that your spatial data is fully and easily integrated across all of your workflow pipelines. The workflows go all the way from modeling with GeoAnalytics Engine to developing dashboards for exploration with Amazon QuickSight. And with that, I'm going to stop sharing my screen and I'm going to pass things over to my colleague Arif Masrur to look at a demonstration of how this all works in the AWS environment.
Thanks, Sarah. Hi, everyone. Thanks for joining today. The goal of today's demonstration is to present a big data-driven data science workflow that leverages ArcGIS GeoAnalytics Engine in AWS EMR environment. And in this workflow, we'll show how you can process your big data at scale to spatially model and predict rideshare demand in the city of Chicago. We have chosen this use case as it poses a really big data problem for rideshare providers and transportation planners. As you can probably imagine, rideshare data can be very big, ranging from millions to billions of records. And analyzing this massive amount of data can help improve travel and traffic management, urban policy, and even investment decision making. Here is an interactive map to give a brief overview of the nature of this data set. We're seeing temporal patterns of rideshare trips. Size of the blue circles represent aggregated trip counts in those pickup locations. And we see downtown area has the most pickups, as well as airport on the northwest. And since this is the data from 2020, and we see a temporal pattern, that may be well aligned with the COVID-19 outbreak. As we can see, that ride share demands right here start to dissipate from March and never goes back to the January, February level. So to predict ride share demand using this data set that was made available by the transportation network providers, we'll also use some relevant smart location data from Environmental Protection Agency, US Census data, and also Chicago crime data sets. And today, our analytical steps start with data engineering, followed by model calibration and prediction. And in the data engineering, we will focus on the two major tasks in any spatial big data problem, which are geo-enablement and geo-enrichment. And in the modeling, we'll use a geographically weighted regression to understand spatial patterns of ride share demands and underlying factors. Next, the first thing that we always need to do is import some relevant libraries. And we're going to start with PySpark libraries, the GeoAnalytics Engine library, and some open source modeling libraries, which will enable us to perform our data engineering and spatial modeling. And here we begin. So the first thing that we need is our ride share demand data set from the year 2020. We read in this data in CSV format directly from AWS S3 bucket, and it has more than 50 million records. And these are the point data set because they have latitude and longitude. And as you know, CSV does not store geometry natively. It can have spatial coordinates like this pickup centered longitude and pickup centered latitude, but we need an actual geometry in order to use geographic analysis. And so that's why next we are going through a GeoEnablement and processing step here. We can actually use function like stPoint from the engine and that take that latitude and longitude and turn it into a geometry that can help us actually perform the spatial calculations. And of course, we also do some other standard data cleaning, renaming fields, and making sure that we have appropriate data types so that you are ready for your analysis. Next, we can quickly plot this geometry on a map using the native stplotting function from the engine. And one of the nice features in GeoAnalytics Engine is when you are plotting your spatial data. There are 4 different base map types that you can choose, which provides some nice geographic context. So for instance, in this particular location, we see the roads and the basic layout of the city. Whereas if we did not have those base maps, it would be just a bunch of blue points on the top of white background, which would not be very helpful for understanding our spatial distributions. And also, just to point out, in this case here, we see a bunch of blue points stacked on top of each other because this is a time sequential data set on a street base map, and each of which these points, they contain aggregated counts and other relevant information about ride share trips in Chicago. But how to better understand spatial patterns from here? For that, next we are going to aggregate these points into census tracts polygons. Here we bring in census tracts polygon. That's a file of Chicago from S3 bucket. It gives us polygon geometry, and we can use this aggregate points tool to quickly take all of our points, over 50 million of them, and identify which census tract they fall in, and then give us the count or the mean statistics for all these different variables. And after plotting this, you can see that the downtown core area here, where lots of trips are originating, and we can see this O'Hare airport area, it's really lighting up because these are the 2 places that really see way more trips than any other location across the city. And of course, trips in the rest of the city is fairly evenly distributed, but those 2 spots, they really have huge uses. But we might also want to look at the data in a different level of aggregation. For instance, what if you don't want to use, you actually want to use hex bins instead? Because sometimes a standard administrative boundary like this is not the right geometry to be using. maybe you don't want zip codes or census tracts, but you want something where you can actually see more of that smooth and continuous change of patterns across space. So we can convert the data into the Uber's AS3 hex bins, because that gives us something that moves away from those administrative boundaries and any artifacts that might introduce into our data. And so here, what we're doing is the exact same aggregation that we have done just the cell above. But instead of using census tracts, we are just using the AS3 bins. And also, once we interactively visualize this output, the bins with those aggregated attributes like trip count, average fare, and tip amount, we start to see some more granular patterns that can help us hypothesize these variables relationships before actually going into the modeling phase. Next, we'll briefly look at the temporal patterns, since we will perform temporal predictions. So we can pull up a quick table here, as you can see, that shows daily counts based on the week of the year. And the chart below here shows a temporal pattern that follows COVID-19 outbreak starting around March. And we will take this into consideration in our modeling. And again, this time slider map gives you a spatial perspective of this temporal pattern we just have seen. So with this rideshare demand data that we have aggregated at the census tract level, we want to actually answer questions like, what factors influence rideshare patterns in Chicago? Are there spatially varying relationships between rideshare and those factors? And for that, we'll calibrate a spatial regression model and predict into the future. But to do that, we need some relevant explanatory variables that you can imagine. So we're going to bring in 3 supplemental data sets. And one of them is the smart location database, which is coming from EPA. That data set is at the census tract level, and it has some interesting attributes like residential and employment density, access to destinations, like things like walkability, distance to transit, etc., which can be really informative of people's travel behavior. Next, we bring in census tract data. Census data from the Esri Living Atlas that gives us demographic variables like population density, educational status, etc. And we're also going to bring in Chicago boundary file, because we're going to need to clip our data sets so that they all correspond to the same geographic area. And we're also going to bring in crime data set, because I think the crime data is really interesting in this case for being able to explore how that might impact rideshare demand. In this cell, in order to bring these data sets together, I'm going to use this clipping tool in GeoAnalytics Engine. And what that allows me to do is to take that Chicago boundary and cut down my crime data set and also my SLD data so that they all fit into the same geographic footprint. And then I will do, here I'm doing a little bit of extra cleanup just to rename fields and make sure that they are ready to go for our next steps when we actually go to the modeling. Like before, here using aggregate point tool, we aggregate all our supplemental data into Chicago census tracts. Next, since today we are interested about spatial prediction into the future, here we split our aggregated data sets into 2 temporal periods from the start of the pandemic to October for model calibration. And then we predict rideshare demand for the November-December period. We're not done yet. So probably you already have noticed that. Now that we have one more step before we get into the spatial modeling, because we need to make sure these 2 data sets all talk to each other, because we have got to have the attributes in the same data frame. And that's why we join our aggregated rideshare data and all of those enriched supplemental data sets that we have just created. And we can do that with a simple spatial or attribute join. In this case, I use attribute join since both data frames, they have GeoID at the same common census tract ID column. But if you did not have one of those and you needed to do it spatially, GeoAnalytics Engine also has a number of tools for doing spatial joins. So you could join them based on geography as well. And now let's go to the really fun stuff, that what we actually wanted to do today, which is geographically weighted regression. And I love geographically weighted regression personally, as it allows us to model spatially varying relationships and predict by fitting a regression equation to every feature in the data set. And those of you who are already familiar with it, you know that GWR can be very helpful to answer questions like, does crime occur near places that have certain demographic and economic profile? Or in our today's case, are the factors influencing high ride-share demand consistent across the study area? Before performing GWR, we need to actually explore our data set to see how they are correlated and is there any multicollinearity. It's a typical step in all statistical modeling, as you know, and we address it here as well, which gives us a subset of variables that we can just use in our next model calibration step. GeoAnalytics Engine provides a tool for GWR, but today I'm using an open source library called MGWR for multi-scale geographically weighted regression that you are probably more familiar with. And MGWR allows each explanatory variable to operate at a different spatial scale. And just to make a point that you can choose any model you want after you have all the smart data sets that you need through the data engineering steps that I have shown. And here, as you can see, I am going to use 3 sets of explanatory variables that passed my multicollinearity test. Those are violent crime, employment density, and population density. These 3 variables are very interesting because they come from those 3 supplemental data sets. Now I'm going to set my dependent variable to be log scaled trip count because that's what I want to be actually predicting. So after we have calibrated our model, we move to the prediction step here. And I'm just quickly showing the spatial distribution of the ground truth trips counts from November and December period that we will compare with our prediction against. Now, I might want to actually write this data to a feature service which allows me to visualize exported data in different ways in our ArcGIS environments. But of course, you can export this data also to different data lakes and warehouses and formats like Parquet, GeoParquet, GeoJSON, and so on. And after actually running the prediction step here, this table actually shows you the prediction output, the prediction, the column, and associated point geometry. Next, what we do actually is we compare. So using this swipe mapping from ArcGIS online, as you can see, you can compare actually these 2 layers. One is the ground truth, another is the predicted outcome. When we visually compare the predicted values against our ground truths, this is our ground truth that you are looking at. And now you're looking at our prediction. We see that MGWR performed reasonably well, especially based over the downtown area and the surroundings. And it's worth noting that this prediction we have shown today as part of this demonstration is the most simplistic scenario which we can be really involved in different data and use case scenarios. You can also tune this model by bringing other appropriate explanatory variables and different parameters relevant to your problem. So to sum up, the key takeaways from this demo today are GeoAnalytics Engine empowers a data science workflow with spatial. And now you can easily geo-enable your data with location information and enrich them with non-spatial data sets, which can be used in downstream spatial modeling and prediction. And you can do all these seamlessly in your cloud environment at scale. Additionally, beyond spatial modeling, you can take these spatially smart data sets that we have created to use in your machine learning models also. With that, I will hand over to my colleague, Damion.
Thank you, Arif. All right, thank you, Arif. So Arif went through creating that data and going through a notebook. Now, what happens next? We had some output from that data. And what we did was we took some of it and we pushed it into Amazon QuickSight. So what is Amazon QuickSight? It is a unified BI for analytics needs. It is built on using some of our machine learning capabilities and using natural language query. So you can go into Amazon QuickSight and use Amazon Q to help you build out some of these analytics. And if we go to the next slide, we have a couple examples. So QuickSight allows you to bring in that data in CSV format or directly to the from the data lakes. You could run a bunch of queries on that data, but it also allows you to bring in a lot of other data sources. As you can see in some of these examples, some of the notebooks some of the notebook cells that Arif was using, we were able to pull that into QuickSight as well. and then some of the highlighted maps showing traffic patterns that was pulled in from ArcGIS Online and their traffic relief map. QuickSight also allows you to be able to share this data in different formats. So I could have internal data that I want the internal stakeholders to see or be able to look at, and then externally available data. So things like want to show like the actual demand at a certain point in time or traffic patterns, and we want to make that available for everybody else to take a look at and say, okay, maybe now is not the best time to try to grab a ride from downtown. We should probably wait a little bit because of traffic. There is also the ability to use QuickSight on a mobile application, and that also gives you a little bit more flexibility to send this data out across the organization. And then with that, we're going to move to some resources in the next slide. Yep, and questions. Before we go to questions, I want to thank my colleagues, Sarah and Arif, for leading us through this today, and the amazing folks at Data Science Connect for helping facilitate. And with that, questions. All right, so I'm gonna go back to questions on chat there, and the first one was, why would someone buy this product versus just buying ArcGIS or another open source system that does this already? What does it do better or easier? So I posted a comment in there from the Esri standpoint. You know, infra is hard to set up by yourself, especially if you don't have the cloud skills or the developer skills to try and set up some of these environments. So we make it a little bit easier to use some of the managed services that we have to set this up. And because we do a consumption model the way we do it per second billing, it makes it a little bit easier to get done and know what you're putting out there. In terms of ArcGIS, I'm gonna let the Esri.
I can totally jump on that one, Damion. Yeah. So in terms of something like using ArcGIS, I mean, you really think about the scaling problem at this point. You know, a lot of the reason for moving into one of these cloud data environments with GeoAnalytics environment is that you can really just scale up a lot more effectively. So you're getting to a point where the analytics can't run at the speed in which you need them to run. For instance, you need a model to run every hour and it takes 70 minutes to run in ArcGIS. That's not going to be a successful model for you. But by being able to move into an environment like EMR, where you can spin up larger computing resources as needed, you can do analytics that really are just going to be performant at the scale that you need them. So you might be moving to it needs to be faster, or it might not even be able to complete with the other resources that you're working with. So another reason that somebody might look at this product versus just something like ArcGIS is I've seen a number of organizations that are starting to move to centralize their data more in these cloud environments to begin with. So if you're centralizing data in S3 buckets and you want a way to easily access those and work with them, and you're already working in a data science environment, you're creating notebooks, and you have spatial analytics that you want to pair with those analytic workflows. This is going to allow you to do that, where you can take advantage of all of the resources that you get from being in an Amazon, AWS, and EMR environment, but you also get all of those spatial analytic advances that you would have from having an Esri environment, and you're just merging them together into one place. Awesome. And I'll just also point out, I mean, we do have a number of additional resources. The QR code that's on this slide points to a post where we have a series of resources that are related to both AWS and to Esri, as well as the partnership between AWS and Esri. So really thinking about how being in both of these environments together is giving you a value add. It's not that you just have AWS or you just have an Esri environment. It's like 1 + 1 is actually 3 in this case.
All right, moving on to the next question. People from Esri can confirm if we need an active Esri account with access to this package to test these notebooks.
Yeah, so I'd say with these notebooks, so if you wanted to actually run these notebooks, you would need to be able to use GeoAnalytics Engine. So you would need to have a license for that. But at this point in time, we don't actually have the notebooks posted, but if you keep an eye on the community resources for GeoAnalytics Engine, and we do have a link to that from our resources page, We do have plans to put together some additional resources related to machine learning and doing some additional documentation about some of the processes that you can do, including potentially writing up in more detail how this particular workflow went through. We went through this particular workflow, and that would allow you to take a look at that. I also saw, Damion, if I could throw a question to you, because I saw there was a question about government cloud, and can these same concepts apply to other applications such as ArcGIS or Power BI? And I saw that you had made a note about EMR and QuickSight. So I thought maybe you could address that a little bit, and then we could talk a little bit about the Esri side as well.
Yeah, so Esri, so EMR and QuickSight is available in GovCloud. So we can run these applications in GovCloud securely. And then I guess it's used within AWS GovCloud space. Yeah, so when I say EMR and QuickSight, these are services from AWS that are available in our cloud GovCloud services. And you should be able to run that on there as well. So then questions to connect to Power BI or ArcGIS. So you should still be able to connect to ArcGIS if that is deployed on EC2 instances inside of GovCloud as well. And then the next one there was, could we utilize the same codes within the notebook to utilize within ArcGIS, Power BI, or Tableau?
I mean, I would say the code would be different, but you can use the notebook to generate the resources that you need for those. So for instance, if you want to get data back out into ArcGIS desktop product, for instance, the ArcGIS Pro product, you can write many different spatial formats. For something like Power BI or Tableau, so long as you're writing your data into a location that you can access with Tableau or Power BI, you would be able to read those files back in. I know for Tableau, for instance, if you wrote your spatial data out into a feature service, Tableau does have the ability to ingest Esri feature services directly. So it's really a question with those other products of getting the data to the right place so that you would be able to access them.
Moving on to the next one, can you use this product to induce ArcGIS to generate heat maps of where members of a group are?
We could definitely generate heat maps. So if you have point data and you want a heat map of things, yeah, it's just a matter of using the tools to generate the heat map based on the distribution of those point locations.
Okay, we have another one coming in. Do you think hexagonal spatial data can be expanded to various disciplines? For example, agricultural production.
I love hexagons. Anybody who asks about hexagons is totally my friend. I think so. Yeah, maybe if you could type in a little bit more detail about that. Looked like Leandro who wrote that question. Hexagonal spatial data. So when you bin data, I mean, there are a lot of considerations with binning data, and I mean, I could give a whole webinar on my feelings about hexagons and spatial binning, because there are a lot of really interesting map projection problems and data analytics and accuracy issues. But expanding a hexagonal spatial grid for various disciplines, so long as the data is appropriate for hexagonal binning, you have these point locations that occur in discrete locations, and it makes sense to count them up inside these hexagonal bins. And so long as you're creating those hexagonal bins in a way that they are being used appropriately. So for instance, you're thinking about what is the geographic extent of the region that you're working with? What is the potential area error that comes with creating hexagonal grids? Because the grids, we live in this spherical world. And so any kind of gridding that you do in a planar environment, even if you're really taking fairly careful consideration to the map projections, you're going to have some sort of impact, either a visual impact on the results at the end or an analytical impact on your calculations. So long as you're thinking about those problems, thinking about the scale, thinking about the actual data that's going into it, hexagonal bins are a great way to look at point data. You just have to be careful. And feel free to reach out, and I will tell you all of my feelings about hexagons. And since I'm talking, so I used to be an academic at a university, and probably the best title of any paper that I wrote You can look this up and find it. I've been told it's highly approachable as far as academic papers go. Shapes on a plane. It was all about, and I got Damion to laugh. So that made me feel good there. Yeah, shapes on a plane. It's all about hexagonal binning and the impacts of map projections. So it'll talk a little bit about some of those specific concerns. And I will say that the editor of the journal did not approve the graphic that I made, where I took the snakes on the plane logo and just shoved some hexagons on the snake's teeth or fangs. Apparently, that was not appropriate for a cover for the academic journal. I don't know why.
I'm sure we could get Sam Jackson to read it, and that would be perfect.
Yeah. All of these hexagons, all of these shapes.
All right, a couple more. Do you have libraries of car travel times or walking between different points? I guess we're talking about data sets here. Yep, so just different data sets. You should be able to get GPS data sets available online. Another one from Bill Bentley. Oh, yeah, sorry, go ahead.
I was going to say, yeah, it sounds like you're looking for network analysis data sets, and there are a number of commercially available network analysis data sets that would have travel times and walking speed times, things like that.
Footfall, yep. Things like that. Footfall traffic, yep. So another one here from Bill Bentley. Will this software handle moving objects?
So GeoAnalytics Engine itself is not designed for moving data. So if you want to be able to do real-time analytics, there are other products that are really more tailored to doing that. For instance, Esri has a product called Velocity, and Velocity is specifically designed to work with moving objects. So I would look at that. Though I've had the question before of, will this handle moving objects? And sometimes there's a little bit of kind of a different opinion on what moving objects means. So I want to say, if you have things and you want to analyze them as they are moving, Velocity is an option to look at. If your question is taking trajectory data that has already been collected and looking at those paths, then GeoAnalytics Engine could be an appropriate tool for doing that. It's really a question of whether you're talking about, is it actively moving right now, or I have data from 5 minutes ago and I want to understand those pathways.
Okay, awesome, thank you. And then the last one I see here with an upvote is, can web applications be built on top of the GeoAnalytics Engine? Example, Streamlit, Flask, etc.
So that's a great question. I mean, I think if it's really going to depend on how you're communicating between these different products. For GeoAnalytics Engine, you do need to have an active Spark session and you're running code against it. So long as I guess you have an active session and you're able to pass things into it and get things back out of it, it may be possible. I have not tried this. I have not done it. I'll admit my experience with Flask and Streamlit are not it's not extensive. Also known as almost non-existent, but it would be something I'd be willing to talk about in terms of what it is that you're interested in trying to do, and we could talk about what potential options might be.
Okay, I think that gets us all the questions in the question window. Just switch them back to chat for a quick second.
There is one. What is the best format to export multiband raster data to use in deep learning models? I don't know if you have covered that, Damion.
No, I didn't see that one.
That's all you, Arif. That's all
you.
So this is about exporting multiband raster data set. At this moment, Sarah, that you're aware that we do not export raster directly in GeoAnalytics Engine. If please correct me if I'm wrong, but you in our future release, you should be able to actually get the raster and extract the values from the rasters, and then export those values in a shape, like polygon and points. So that should be doable. Yeah. Is that the last question that we have?
I think so. Just switch back to regular chat.
Yeah, I'm not seeing any additional questions, but I do like in the chat that people are sharing that hexagons are the bestagons. So I appreciate all of you, and Since it seems like maybe we're running out of questions, I do want to thank everybody for joining us today. It's really been a pleasure having the opportunity to talk with you guys about geospatial data science at scale with Esri and AWS. So I've enjoyed the opportunity, and I'm looking forward to future conversations.
Yeah, thank you guys. We want to thank our friends at Esri and AWS for such an excellent, informative presentation. For all of you in the audience, don't forget to answer the poll questions on the right side if you haven't already, and in particular, indicate if you'd like to be contacted to learn more about Amazon EMR. And if you missed any of the webinar or want to rewatch it later, it'll be available on demand at this same link immediately afterwards, so you can go back and catch anything that you might have missed or want to rewatch. We appreciate it. It's been a tremendous webinar, and want to thank everybody for your attendance and participation today.